am Anastasopoulos from Carnegie Mellon University, and I'll describe the work I did with Neubig on multilingual word representations and whether they should all learn to speak English. As NLP is moving towards multilingual and polyglot systems, cross-lingual representations become increasingly important. In bilingual settings, obtaining such map representations is typically a two-step process. First, we learn embeddings for the two languages, let's say Italian in blue and Greek in red. And then we use some machine learning model to learn a transformation that aligns the two representations. Such cross-lingual representations can facilitate cross-lingual transfer for a plethora of common NLP tasks, including tagging, parsing, and document classification. They are also crucial for unsupervised machine translation and in general have found wide applications that I will not list here. Bilingual lexicon induction is basically a way to evaluate how well this mapping of word representations worked. By picking pairs of words that are nearest neighbors in vector space, we can extract a lexicon and then compare it with a gold standard one. A lot of progress and many approaches have looked into the task, and in fact, the state of the art has significantly improved throughout the past years. However, we identify a major issue in that the majority of previous work evaluates their methods on English or European-centric settings. This is partly due to necessity. The Muse dictionaries that most people are using, even though they are an amazing resource, are between English and 49 other languages. One cannot help but wonder, though, if the performance is as good on more diverse language pairs, and this is in fact the first question we study in this work. Before we go to the experiments, though, let's look a bit further to multilingual alignment settings. Extending this vector space alignment approach to a multilingual setting is straightforward. For instance, starting with 4 languages, let's say Italian, Greek, Hindi, and English, we can use a bilingual method to map each language into what I will refer to as the hub language, in this case, English. Or we can align all of them jointly, taking into account alignments between them when mapping them onto the hub space. Now, you'll notice that the hub language remains invariant in this process. In these examples, I used English. A natural question, hence, is whether the choice of the hub matters. Previous work used English as the hub, almost by default. What if we instead aligned everything to the Hindi space? Or what if we used Italian as the hub? Turns out the hub matters. We will discuss this further in the experiment section. In this work, we argue that we need to be evaluating on as diverse language pairs as possible in order to obtain trustworthy results. To do so, we need to expand our evaluation dictionaries. One way that we use to produce new dictionaries between diverse language pairs is by triangulating the existing ones through English. The process is straightforward. Imagine a Portuguese-English dictionary that translates the words trabalhar and emprego to 2 English words, work and job. Now take an English-Finnish dictionary and translate these 2 words into these 5 Finnish words. Now we triangulate through English and we get the following pairs. Now, not all of these 9 word pairs are correct. The English word work can be both a noun and a verb. You can go to work or you can work on a project. We ensure the quality of the dictionaries by tagging all words with their part of speech or morphological analysis, and then we'll filter out the triangulated word pairs that have different parts of speech or different morphological tags. Following best practices, we also remove proper nouns because they can obscure the results. In the end, more than 60% of the triangulator entries are filtered out, and we are left with much higher quality lexicons. Another important direction is to create dictionaries for low-resource languages, going beyond the 50 languages already present in Muse. As a proof of concept, we also extracted high-confidence alignments from parallel data in 3 more languages, Azerbaijani, Belarusian, and Galician, as an illustration of how one can create new dictionaries in low-resource languages. The process is detailed in the paper. Overall, we end up with more than 4,000 training and evaluation dictionaries among more than 50 languages. Now, with our diverse lexicons at hand, we can perform interesting analysis. In all experimental settings, we start with fast text embeddings. We align all the embedding spaces for that experiment, either in a bilingual or multilingual setting. And then we evaluate the resulting spaces through lexicon induction, comparing to our constructed dictionaries. We first start with simple bilingual settings, where we evaluated established methods on all language pairs. The main takeaway is that the quality is vastly different across the different language pairs. For example, in English-French, the accuracy is above 80%. In English-Portuguese, it is above 70%. In more diverse pairs, though, like Ukrainian-Hindi or Korean-Russian, the accuracy is below 20%. This basically means that in practice, we have failed to align these two embedding spaces. An interesting finding is that typological distance seems to correlate with bilingual lexicon induction accuracy. Aligning two languages that are pretty similar, like Slovak and Czech, leads to high accuracy. But as we move to more distant language pairs, like Slovak-Russian or Slovak-Turkish, the accuracy drops significantly. Moving on to multilingual settings, we mainly performed two studies. In one, we aligned 10 European languages, also including our 3 low-resource ones, Azerbaijani, Belarusian, and Galician, along with other high-resource ones. The second study, we aligned a set of 7 slightly more diverse languages, including Hindi and Korean. Now, in each of these settings, we experimented with each of these languages as the hub and evaluated on dictionaries on all language pairs. The first study compares the performance on the same test sets using different hubs. It turns out, as I alluded to before, that the hub choice can indeed somewhat affect the lexicon induction accuracy. Here's just an example from our second experimental setting. We evaluate on Russian Swedish, and the accuracy varies from 36.7% when using Swedish itself as a hub to over 41% as we vary the hub language, an almost 5% swing. We also found that English is the best hub language for multilingual word embeddings in only about 20% of the cases. So, to answer the talk's title question, no, cross-lingual embeddings shouldn't always learn to speak English. All languages are, in fact, the best hub for some language pairs. So, how much can we gain by picking the best hub? We can estimate the expected gain by picking the best hub by comparing the average improvement across all language pairs if we actually pick the correct hub. Let's assume we have an oracle that tells us for each evaluation pair which hub we should use. These numbers gives us the expected gain in this case. For example, this number means that for the language pairs where Swedish is the best hub, if we indeed used Swedish, we would on average gain 1.7 accuracy points compared to all other languages. As another comparison, let's see how much we would gain or lose by always picking a language as a hub. Now, this number means that if we always use Swedish as the hub, we would lose 0.2 accuracy points compared to the average case. An interesting point is that English is not a bad hub per se. It has a positive gain overall. But for the given set of languages, Russian is actually a better choice as a default language with an average gain of 0.2 points, 0.4 points. I don't have time to cover everything here, but in the paper we also attempted a correlation analysis to find the best hub, to try to find the best hub language a priori. We also showed that the hub matters for downstream task performance, and we additionally discussed the differences between bilingual, trilingual, and multilingual settings. The main takeaway is that we should be thinking more about language diversity and the way that we construct our experiments. We should try to evaluate on as many languages as possible and make that set of languages as diverse as possible. To this end, in the hope that we'll steer the community towards more challenging evaluation scenarios, we provide 4,900 training and evaluation dictionaries. Regarding multilingual word embedding specifically, we should consider the choice of the hub language as another hyperparameter to be optimized, as it can have a large impact on the final results, both for lexicon induction and other downstream tasks. Picking the best hub language a priori is not easy, and it is definitely a challenging future research direction. We have released all data and code, and we also have written a blog post outlining the most important findings of the paper. Please feel free to reach out to us via email, Twitter, or other mediums if you have any suggestions or questions. Thank you.